Hey everybody, this is Larry. This is day 2 of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's bomb. Today I ran about 5-6 miles. But the real cardio session was me cleaning up my apartment a little bit. I don't know. I don't know if this is important or even interesting. Let me know in the comments your bed situation. But at some point my bed just failed. I was having back issues, and I just didn't know what it was until I figured out, well, it was my bed. I've had the mattress for about 10 plus years, something like that. I don't know when. So, well, just need a new one. Anyway, but as a result, I cleaned up a lot of my apartment so that I could, get a new mattress in. And I was like, okay, it's time to refresh some stuff. Went to IKEA, all the good stuff. So yeah, so that's the real cardio today. And anyway, that's it. That's all I got. But let's take a look at today's problem. We have 135, candy. Okay, there are n children standing in a line. Each child is assigned a rating value in an integer array. Rating, you're giving candies to these children subject to the following requirement. Each child must have at least one candy, okay? Child with a higher rating gets more candy than their neighbor. Return the minimum number of candies you need to have distributed to the candies to the children. Okay. I mean, I think there are a lot of ways you can think about this problem. Of course, if you're more on the sloppy side, n is going to be too big for n squared type thing, right? The way that I like to think about it is maybe in a topological sort kind of way. And what I mean by that is that, and honestly, there are really only two directions, right? What I mean by that is that, okay, we topologically sort by either the minimum candy or the highest candy, right? Because the minimum candy makes sense because, or I think to me, the first intuition that I would have is to start giving candy that has the lowest rating, right? Because the lowest rating, then you can figure out that, or the current lowest rating, because then now you can figure out that, okay, that's the current lowest rating. So then that means that I can now look at the neighbor and just make sure that I have more candy than them, because I assume that my neighbors would have already be done, right? And that's basically it, really. Yeah. And so it's topological sort. And in the same way that in a topological sort, we can just do like in degree is equal to, say, 0 times n, because we have to go through them, right? So then here, if I minus 1 is greater than 0, and rating sub I minus 1 is less than rating sub I, because if it's less than, that means that they go first. So that means that they are a prerequisite to that here. So that means that there's in degree in I, right? If I plus 1 is less than n, and rating sub I plus 1 is less than rating sub I, same idea, right? I actually forgot to just write this. And of course, you can even write something like for k in range, in I minus 1, I plus 1, right? And then this is just going to be k, right? So then now you could rewrite this as if 0, and rating of k is less than rating sub I, then in degree of I increment by 1, right? And this is very standard topological sort how I'm doing it. As soon as you see it, then you kind of figure out how it applies to this problem, right? These are the edges. You only care about his neighbor, and there are only at most 2 dependencies, of course, of having lower neighbors, so they go first, right? And then we just go another loop. You don't really have to. You can actually probably put in the same loop, but I like to kind of separate them out, right? So then now we have a topological sort type thing of if in degree sub I is equal to 0, q dot append I, right? And then that's basically it. And then now we have the answer is equal to, actually, I know that I could set it to n or to 0, but I'd like to set it to none so that if something fails during testing, I could see that it is none and that maybe I didn't throw out everything, right? So current is equal to q.pop left, right? And then now that means that at this point, this current number is as small as it can be, right? So that means that, okay, so current, we just not current. So the current is the current index, and then now maybe the candies is equal to 1 because you have to have at least one candy. If maybe we'll do the same thing that we had before of I minus 1, I plus 1, right? So if this is within bounds and right, and that means that, what does that mean? This means that the number of candies is equal to max of candies and then answer of k, right? It means that we've, I guess in this case actually, yeah, in this case it means that we've already parsed that just by definition. And so it is that candy plus 1 to have the most. And then at the end, we just write answer sub current is equal to candies. And then you could actually tie this in together as well. But for now, for today, I like to separate them out, which is the same thing again, right? We look at the neighbors and then we want to relax them and queue them into the, we'll add them to the queue, right? So if, and if the ratings of k is greater than ratings of I, then now in degree of k subtract by 1 because we had it set up earlier. And then now if in degree of k is equal to 0, that means that we are Gucci with the index k to be processed next. So then we put it on. And then at the end, we just return answer and we should be good. Hopefully. Oh, it's ratings? I mean, I think I use rating everywhere and not ratings. So I think it's easier if I just can change this. Okay. That's the one that I worried about. That answer sub k could be none. But that's also good in that it lets you know that like something's weird. How can this be true? Because we have to process these before if in degree is 0, right? All right, let's print it out real quick. I mean, maybe it's something silly. Yeah, it doesn't even, oh no. So 1. But, yeah, so that's this first. Candy sub, rating sub k is not less than I, right? Because we're doing 0. I don't get it. Wait. I'm a little bit confused. 0, 2. Oh, I guess this just prints. No, that doesn't make sense. Did I mess up on the I? Oh, I'm dumb. I use I for some reason, but what I mean is current, of course. So yeah, okay, that makes sense. And in this case, it is current plus, because I had it, I guess it's copy and paste a little bit mentally from before, but yeah, okay. It's the wrong answer, but at least, you know, it's better than nothing, right? Oh, I returned the thing, but I don't return the sum, so I think we can just return the sum. Clearly, I that part is easy to fix. Looks okay. Let's give it a quick submit. Hopefully no silly wrong answer, and we are good. Apparently there's an easier way to do it, because, or like a a quicker complexity for it. I don't know. I don't feel that bad about it. This is, so what's the complexity, right? This is going to be linear time, linear space, because we only have O of n number of nodes and O of n number of edges, because each node can have at most 2 edges. And we just do a couple of loops, right, for each of the edge. So yeah, linear time, linear space. I don't know why I'm so much slower than the other people though, but I guess you could do it in 2 passes. But that's I don't know if I could prove that though, to be honest. So it's kind of apparently I did this problem like 5 times. Did I do it the same way? Okay, it seems like I mostly do it the same way. Oh, this way no. This is the same. Oh, wait. Well, I mean, yeah, okay. This is a little bit cleaner because I sorted by rating. That's what I said I was going to do, but I talked about topological sort, and I thought this would be the way that I did it would be cleaner. But this is more topological sort. I mean, it's just more consistent, as you can see. But apparently, running time not so Gucci. But that's okay. I don't care that much. Right. All right. That's all I have for this one. Let me know what you think. Apparently, I solved this like 5 times. I don't remember even one of the times. But yeah, thanks for watching. Have a great week, everybody. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.